Hi there, I'm Alan Beck from Concretene, a green tech company from Manchester that's using nanotechnology to help decarbonise the construction industry. We're in a community of firms using graphene and other 2D materials, based at the University of Manchester, and all trying to help shape a new era of more sustainable engineering. So we thought we'd try to bring some of those ideas together in a podcast. In this interview, our Chief Operating Officer Mike Harrison talks to Dr Liam Britnell, the Chief Technical Officer of Vector Homes, about his potential solution to the housing crisis.
Today we're having a little bit of a conversation with Vector Homes, and Liam, you're with us today. My name's Mike Harrison. I'm from Concretene, and we're both partners in the Graphene Institute in Manchester, and we thought it'd be, as part of how we collaboratively work as an ecosystem, we thought it'd be great to kind of explore what you do, what we do, and whether there's any common ground, and ultimately whether there's a way in which we can help each other as we both strive for success in what is a very, very challenging market at times. So maybe we could start by, if you could explain who Vector Homes are.
Sure, absolutely. So, and thank you for having me on. So, Vector Homes is setting out to cut carbon primarily, but also cost and complexity in construction. So, it's a nice tagline, but what does it mean? So, from the point of view of carbon, there's been a huge amount of work over the last 10, 15, 20 years on improving the energy efficiency of buildings. So all of the energy that gets used and therefore generating carbon during the lifetime, the heating, cooling, lighting, etc. Less focus has been placed up till maybe the last 5-10 years on the carbon that's created in producing the materials, transporting the materials, and so on. So I think we're following sort of similar footsteps to some of the manufacturers in that regard, but I think we're doing it quite a different way. So our approach is really through resource efficiency, using recycled materials, natural materials that are primarily byproducts or waste products from existing industries, and that's the sort of crux of how we're able to look at reduction of carbon overall. Vector Homes was born out of ideas, I guess, that were generated by a group of people who are working in the same building we are now in Geek, in the Graphene Engineering Innovation Centre, and it's really sort of spurred on from there in the last couple of years.
So you're a house building company?
I would say that at heart, we're a materials development company and a building systems design company. I would agree that a name probably doesn't always make that clear, but we are, I think the simplest analogy would be to think of IKEA. So we are designing the system, we are manufacturing the materials, we will be manufacturing the final components, but ultimately the deliverable, the house building, will be done by a collaborator, a partner, someone through a JDA.
Which is really interesting. So if you look at the IKEAs of this world, and there's huge, we know what they are now, but they've been going for quite a long time, and they had a fair journey along the way. So how's it going? What are the technical challenges that you're experiencing, and how tough is it to get a new material or materials into a house building system?
So it was challenging, I guess, is a simple answer. But I think there's a number of challenges that derive from, there are technical challenges that come from the use of a new material, a material that is not commoditized, that is not well understood, and I'll pitch up on those in a second. There are other challenges that come from, industry inertia, and of course the time lag of things like standards and regulations, which I think aren't so critical for the kind of materials we're developing, but I know certainly in other new construction materials, just even the way you measure certain properties is inappropriate for some of the new materials that are being produced, think particularly around porosity and things like geopolymers, for example. But in technical challenges, I think, so we're all in the graphene ecosystem, let's call it. The industry or the production of graphene has come a long way, as you well know, in the last couple of years. But I don't think we're still far from it being a commodity, something that you can while there are some economies of scale, it's not so easy to have competition between suppliers because everyone is supplying something that is quite different. And so you're not able, even if you've got that economy of scale, to perhaps use sort of bargaining power between suppliers.
You mentioned, as we all know, graphene is challenging and manufacturing isn't commoditized yet. So not everyone will understand what that means. So what do you mean by that?
So let me explain in a bit more detail. So graphene is a fairly simple material. It's a single layer of carbon atoms from a piece of graphite. Far less simple to produce, certainly at scale. Probably 10, 15 different production methods, all of which have their own, produce a unique form of graphene, let's say, that has slightly different properties, which may even vary from batch to batch. So when I'm talking about the industry coming a long way, it's from several points of view. So one is the sense of scale. So we've gone from grams to kilograms to ton scale production. We're talking about stability, or consistency in the properties from month 1 to month 6 to month 12. And we're also talking about the standards that come along with that, because how do we judge supplier 1 versus supplier 2 on the same scale?
Which is so from our perspective, as Concretene, we have seen that there are many manufacturers, as you suggest. They're all subtly different, and our product just is a singular product. So within your design solution, how many graphene enhanced products do you have in your portfolio that forms the Vector Home solution?
So broad strokes, we have 2. So one is insulation, one is sensors.
Yeah.
If you break each of those down, certainly within the sensors, we're already kind of looking at 4 potentially products within that. They're quite different. Within the insulation, we're talking about recycled and natural materials. So quite quickly, you probably get to 10 or 15 what could be just talked about distinct products, but broadly within those 2 sort of arenas. Yeah.
So the sensors that you talk about are really interesting. So what sort of sensors do you need in a house?
Well, it depends who you speak to. There's plenty of people that tell you need a myriad of sensors, and actually that's not far off the truth. So if we look at pick up on one particular thing that's topical, is the issue of mold or mold risk within houses. So in order to make a reasoned judgment on whether there is mold risk, you need to have an understanding of the temperature over a certain time, the humidity. Even the people, housing associations or private developers that are putting these in, might only put 1 or 2 sensors, 1 per floor or 1 per room. Even that is probably not enough to really, you've got mold growing. If you're sensing it on one wall, but you have mold growing on the other wall, the conditions are clearly different in those 2 locations. So, but I think, we're moving towards this idea of a smart home, and that should have both ability to actuate by, open windows or open, let's say, windows automatically to help ventilate, but also to sense, to detect when it needs to do that ventilation. So I think there is a strong argument. I'm talking about lots of things, so humidity, temperature, CO2, all these things can be used to make quite significant improvements in the energy efficiency, actually.
So energy efficiency of the home is essential. What about the carbon footprint of the home? So it sounds almost too good to be true. We get a super smart home that's a lower carbon footprint than the standard product being supplied by the industry today. Is that your offer?
That is ultimately where we want to get to, yes, absolutely. So I think it does make sense to delineate the energy use of the home, and obviously the materials you use go greatly into dictating that, how well insulated it is and so on, and the energy that's intrinsically built into the carbon, the energy that's built into those materials themselves, which is how much energy is the production, the transportation, and so on. So ultimately, I personally don't believe that every action you take will involve some energy. So I think getting to a completely zero embodied carbon home is probably pretty unrealistic. if we're ignoring things like offset, for example. But to get to a carbon neutral home in an energy point of view, I think is quite, it's very achievable.
And how are you finding measuring it? So from a Concretene perspective, it's the first question that everyone asks us is, so with if you're using Concretene, what's the carbon, the embodied carbon improvement after we've used your product? So because I get that quite regularly, I'm going to kind of flip it around and say, there's a lot of research, and there's also a lot of potential legislation coming forward. Certainly, planning conditions are certainly growing around the kilograms of CO2 per metre squared for dwellings. Mm-hmm. How are you getting on with that? And what is it currently, and where are you heading towards with yours?
Sure. So, as people might guess, it's a pretty complex system that you're trying to analyse. I think let me just start with where sort of the industry is, and I think there's some improvements that can be made there for a start, because it's easy. You take averages. If you take a steel beam, that might have come from South Wales, or it might have come from India, for example. Those will have quite different carbon footprints because of the different levels of transportation, perhaps different, got electric arc furnaces in one and blast furnaces in the other. So they can have radically different carbon footprints, but we typically at the minute still use an average value for that. And I don't.
So I think what you're telling me is it's kind of average of an average. So
yeah. So to me, it's ultimately quite meaningless if you're trying to make judgment calls, and it doesn't allow for any much. It doesn't allow kind of some of this innovative stuff to flourish. So what we can do is measure the impact of our materials, and we do that through a careful analysis of the different supply streamlines. Of course, this should be all under your ISO 1404, whatever it is, else life cycle assessments. But we can ultimately arrive at a number. But I think we can pitch that number. But ultimately, when we're doing things like, or when architects or developers are doing tender documents, I think we need a bit more of an agile system in which to evaluate different suppliers for that reason. Because
listening to you, it feels like there's a cry for help there. It's somewhere in there that, and I think the industry probably knows that we need to get more granular and more authentic around how we measure the embodied carbon mm-hmm. of the products that we use, and understanding the origin and the total impact of those materials. So it sounds like that's a little bit of a challenge, a technical challenge, but what other things are coming along the line for you? We, from our perspective, we've seen insurability of end products being an issue. Mm-hmm. How's that for you? Have you found insurance an issue for clients when they're using your novel technology?
So I guess one of the main, the large hurdles to get to if we're selling either insulation panels as a product or the homes themselves is building that confidence through warranties or whatever it might be. There's a certain level of necessity in that, of course. We need to be sure that we're building safe buildings. I think the process is long and expensive, and I think that does benefit some people in the industry as well. And I'm not going to be totally pessimistic and say it's there for that reason, but I think it certainly extends timelines and therefore costs, which a lot of small companies can't afford. So I think the way we're approaching it is to look at how our insulation solutions, for example, fit into an existing design, and that then becomes more straightforward to get warranty approval on, and then we can develop from that point.
So that's interesting. It's using the existing codes mm-hmm. and design mm-hmm. techniques is an approach that we're taking at Concretene. So mm-hmm. our product will fit as an additive in the current British standards and Eurocodes. So is that what you're heading to too? So your product will fit within a codified set of standards, so that it's flame resistance or thermal performance or other concerns that asset owners or home buyers might look at. Your product will satisfy those.
Absolutely. So that's the sort of the main target now is to get the various product lines that we have at various stages of development through classified Class A, Class B in fire safety. Gives you whatever you value is being demanded by a certain customer, but to meet the new Part L regulations. I think there's a general challenge to getting these new materials to market, and of course those costs they don't just have take a long time to perform, but they can be expensive, of course, as well. So I think it's part of the reason why we're looking at that whole building solution, so that we can ultimately capture more of the margin, and probably more critically get a much better understanding of what the end customers are actually demanding from the product as well. Because of course you have the regulation on one side, but you also have the specifications from the client. So having sort of direct feedback on those issues or those points is quite critical as well.
You talk about IKEA,
Mm-hmm.
which is very much a shop for everyone, and it pitches itself mansion to maisonette. So where are you, and why are you doing this, and where do you fit, or where does the product fit in the market?
We set out to try and make housing more affordable for the social and affordable housing. So we look at the price that is paid per square metre by housing associations today, and we're told they don't want it to be any cheaper. But then you talk to the housing associations, and I can assure you they do want it to be cheaper. But I think there's a sort of certain uniformity across the market on what people are pitching for. But there's no reason why it can't be cheaper. And you look at countries like Denmark, for example, are paying up to £1,000 less per square metre than we're paying in this country. So there's no reason why it can't be done. And so that's what we set out to do, is try and come up with a set of materials and a system that can be supplied at a cost and ultimately which needs to be passed on to the end, to the occupant or to the owner.
So the purpose, or why do this is global domination, or is there a social aspect of what you're trying to do? What's driving the kind of the move forward? Because we have home builders, don't we? We have a supply chain, arguably a supply chain slightly under stress in terms of the availability of skilled resources. So how does it seems a really tough market entry.
It absolutely is, and I think it's a industry that is, I think probably has for maybe not always been, but for a long time been under people's lack of or loss of critical skills and things from the industry. I think if you look at it as an outsider, as some of the guys at Vector Homes are, we're new to this game. I think you look at it and see, one of the first things you see, there's a huge amount of inefficiencies there, and these are things that we've built houses or built shelters for millennia, right? And there's a lot of things that become entrenched in that I don't think need to be there. So there's a lot of efficiency gains that can be made. Therefore, cost reductions can be made. You're right. We do have a house building industry. I mean, the numbers vary year to year, but typically we're building somewhere in the region of 50% of what the demand is. And this has partly led to the house prices being where they are. I think land availability of land is a key part of that, but also the speed of build. So we're very much focused on building, high performance houses, let's say that, but at a much quicker rate. You have less time on site, you have less lower workforce requirement, and that actually eases your these issues you're talking about in terms of the industry being stressed. And I think if we can this is what we're doing, is trying to come up with a set of materials being much more resource efficient with UK, so materials that are starting life in the UK rather than being imported. We can also cut down on various of these things like transportation emissions and so on. So you're right, it's a heavy lift, but I think it's also one that if we were trying to do it on a small scale, we would be unlikely to make much of an impact.
So it sounds brilliant, and we're really looking forward to seeing you succeed. So how are you going to do it, and when can I buy my first Vector home?
Vector home. So we are on track to be doing deliveries this year. That is our goal. We have more projects than I like to think about, being the guy that's in charge of the technical developments at the minute. So we're looking to significantly expand both the R&D side as well as the sort of delivery side. But yeah, we'll be, and then as these materials come online, become certified, reach to our technology maturity, those will be then folded into future generations. But yeah, we're looking at starting to make an impact soon. And in terms of how we judge that impact, going back to a previous question, I think looking at how many people we've been able to provide a home to that wouldn't have been able to otherwise, in terms of home ownership, I think is one of the things. Metrics that we.
That's a great metric. Yeah. So to be able to say that X or Y number of additional people have been housed for a set investment sounds like a great metric. I think that's very, very, very valid. So we're going to hopefully you have a sample of this house somewhere, I believe, and I'm hoping that we're going to go out and have a look at that in the flesh, and maybe have a look at and touch and feel of it. So where is the first house?
So we're going to have to go all the way to sunny Salford, the other side of the city, or to the other city, I should say. There's a quite remarkable institute called the Energy House 2, which is part of the University of Salford. So Salford University has a long history of expertise in the built environment, both from sort of quantity surveyor side, but also building physics. And the Energy House 2 houses our prototype alongside others from large national house builders. We'll be shooting over there and having a look.
That sounds great. Thank you. Well, Liam, we're now at the Energy House 2 here in Salford. So it's a great opportunity for you to kind of explain a little bit more about your product, because obviously in the studio when we're talking about it, it's much easier to visualize when we're actually next to it.
Absolutely. So yeah, this is our prototype, which is currently being used to test some new innovative types of systems, which I'll talk about more when we're inside. But we're here in the Energy House 2, so this is a facility at the University of Salford dedicated to testing new build technologies. It sits alongside Energy House 1, which is more dedicated to testing retrofit technologies. So we are inhabiting chamber 2 here. There's a twin chamber next door, which is housing some other types of building archetypes. What we're really doing here is from the identification of that problem, that there is often a big gap between design performance and built performance of new housing. So this facility really gives us an opportunity to test that. So we can take the temperature inside here from -20 up to +40 degrees, supposedly able to simulate something like 95% of the world's climate conditions outside of sort of natural weather events, let's call them, and we can vary the humidity across that range at those temperatures, and also simulate things like solar radiation, snow, rain, wind-driven rain, and those things. So really put a new type of building system through its paces.
And that data set will allow you to adjust your product and then presumably come out with some hard performance data around a specific design.
So we're when we started here, we got to a certain point in the design sort of iteration that it made sense to go and actually, build a prototype. So exactly, that's the point. So yeah, so we've put the building through a whole range of those weather conditions. The results are sort of still ongoing, but are being written up by by Salford University, and so that provides that sort of level of independent input as well.
Will that become a public document? Hopefully you're kind of developing your product based on the information you've got, but what's the next steps with that? And as I look behind me, it looks sort of unfinished. There's sort of so are you continuing to work?
Well, I will come to that part of the question in a second, but no, absolutely. So with the houses that are built in Chamber 1, a large report is actually published as part of the outcomes from the funding program, which was a public report detailing what they found and the performance values and so on. So we would be expecting to follow a similar model to that. In terms of how it looks, in terms of it's half finished, so was actually in a state of complete finish around 6 months ago. But what we're really interested in, what's been really beneficial about being here, is that we can actually then go and start testing some other types of technology that are developed by other innovative companies, other startups. So the one that's actually being tested on here now, and the reason why the windows have been boarded up, is a new type of ventilation system where your sort of extract and your incoming fans and everything are all connected together, and doing that in a way that is keeping the warm air within the house while maintaining a kind of clean atmosphere as well.
Brilliant. Which sort of links into some of the things that started our conversation, which is the things that we hope to be doing with you. So from a Concretene perspective, and using concrete products and maybe renders, is when you get to the first build, is to actually use that, to use our product with that. Clearly here it's already built, so there's little opportunity for us here. But do you see that as interesting for your brand and your system to use Concretene?
Absolutely. So everything, I would say the core of everything we're doing on the materials development side is all around the embodied carbon levels, because of course we know a lot of effort has been made in the last 20 years on improving energy efficiency, and we're seeing more and more regulations to that effect. Less so on the embodied carbon side, but it's our belief, and I think many people's belief, that is coming. That whole life carbon is a really important factor, especially when the impacts are in 2024 or 2025 and not spread over the lifetime of a building. So yeah, absolutely. So we're looking at where we can use most of course we'll still have either concrete slab or strips, how we can use new materials that are being developed as part of that system, for sure.
And your technology, which I think you described as a system or a set of components, how does that play into the embodied carbon? Will these components be reusable? So will I be able to buy my house and then take it apart and move it somewhere else and build it again, or is that just a step too far?
No, absolutely. That's exactly what we're looking at. So there's several points. So if we're talking about the frame, so typically when these things are installed, you're putting new holes in. That might be done in a regular fashion, it might be done in a less regular fashion depending on the builder. So one of the core things that we're putting in here is those fixings that can be put in without adding any further degradation to the structure, and that's everything from then dismantlement, and we're talking with people around the idea of material passports, so that at the point of build, that the things, the manufacturer, the grade of steel or type of insulation is all logged, put into a BIM model or a Revit model, so that at the point of demolition you're not then doing a pre-demolition audit, but rather referring back to your original model. So that talks to kind of reuse. There's also elements of that which can be done during the occupancy of a home, so in terms of adding or taking away extensions much more easily than is done now. But in terms of the embodied carbon and where we're looking to drive that down, so primarily what we're looking at is sources of materials that are either reducing transportation associated with them, but usually it's about improving their performance so that you're using less of the material overall, and that's a sort of general trend, and I think one that's probably similar with you guys.
So do you think we could have a look inside?
Yeah, I think we can. Let's go.
So we're now inside, Liam. Great looking apartment. but doesn't look quite finished. I can see a roll of carpet, and what looked as though it has been finished, it now isn't. So what's going on in here, and how does that play into the whole picture?
So absolutely right. So it was fully furnished, very nice job done by the contractors in the first place. But we really see this as a living lab. So the whole purpose of, or part of the purpose of being here, is that we can then start pulling things apart, testing new technologies, testing new types of insulation. For example, you can see in the background here where a section of wall has been plasterboard has been removed and insulation replaced. And then you can see, which I guess we'll talk about a bit more in a minute, but an array of sensors which are then doing the testing. So a lot of these cablings, which of course you wouldn't need in a normal inhabited house, are related to that sort of deep testing that we're doing on the structure itself and on the materials, and alongside, as you'll see around here, various types of ventilation or heating systems which are being installed and tested before they go to market.
And it is very warm in here, and it was very cold outside. So that differential, what is the temperature in here at the minute?
I can't see any of the readings around here, but it's probably around 22, 23 degrees, something like that in here. We're in the middle of a testing regime by Think Air for the smart ventilation system. But yeah, so it really we've obviously designed the houses to be as efficient as they can be. So it's improving the insulation, reducing thermal bridges, and so on. When we were working here, we were a little more than the heat of a few bodies would be enough to heat the apartment.
So plasterboard, I see plasterboard here. Do you see that as a renewable material, or is that something else you're going to look at? Because in construction terms, you consider that a wet trade.
Mm-hmm. So from my point of view, it's a perfectly reusable or recyclable material. And the challenges around it are really more logistical challenges, and how that factors in, and people's perception of what retains value, particularly at the end of its life.
So one of the things that I've noticed in not a lot of the materials that I've seen have graphene in, and obviously our relationship started because we're both spin-outs from the Graphene Institute, Manchester University. I was just wondering whether you could talk us through some of the materials that you're looking at, how you're using graphene, and what the future lies for some of the specialist materials that you're developing.
So we have research programs in sort of 4 distinct areas. So we have post-consumer recycled waste, which I'll show you in a second, natural fibre insulation, which we also have an example of here, both of which incorporate graphene. I'll say a bit about that. And then we also have some things around nanocomposites, which is an area of interest for us as well. But so if I talk to these, so we have this is post-consumer recycled HDPE. So primarily made up of things like detergent bottles and packaging. This is, while not in its native use very good for uses in the built environment, can be converted into a much more higher performing material, use of graphene and a combination of other additives. And that's what enables us to produce something like this, which is a pelletized HDPE graphene composite, which you can slightly tell from the color. So some of the color comes from the pigments in here, and some of that from the graphene. Enables us to produce a series of structures, things like these tensile bars, which are for testing. So we see improved mechanical performance, mechanical strength, as well as significantly improved fire resistance. And if we start with a different waste stream, so one perhaps like LDPE, we're also able to produce foam structures which incorporate graphene, and again with similar kind of property improvements.
And is any of that foam, that looks like insulation to me, is that, are you using any of that in this build or in any of the builds as you move forward?
Yeah, absolutely. So we've incorporated that into elements of the prototype, but certainly it's a material that we're looking at rolling out as part of our builds, after going through the obviously requisite kind of certifications and so on.
And is that a closed or open cell product?
So this would be a closed cell product.
So suitable for under slab construction and insulation where moisture penetration is important.
And there's some interesting things around using molds and things for precast molds for that as well.
So I've got to ask you, what's the big cream cracker?
So it does look a little bit like a rice cracker, I'll give you that, but I wouldn't eat it. So this is actually 100% sheep wool. Yep. So there is an interest in the industry certainly around using natural fibre insulation, things like hemp, sisal and others, wood chip fibre. The direction we've taken is to use this highly technical fibre, as I called it before, sheep wool, which comes from sort of low-grade sheet wool, so not the sort of thing you're going to want to put into a jumper. And actually, Europe, which produces with the UK somewhere in the region of 250,000 tonnes a year, is really seen as a byproduct of the meat industry more than anything else. It costs them more to shear the sheep than they can sell the wool for. So it's actually a drain on farmers' resources, and we've developed a way to turn it into a rigid insulation, which can be used anything from acoustic applications through to underfloors and external wall insulation, which is one of our goals. So starting on the journey of scale up for this material up into standard sizes now.
Great. I think it'd be good now to head back to the studio and finish up our chat. So Liam, tell us a little bit more about yourself, because as a budding entrepreneur, who are you? Where did you come from, and what were the steps that brought you to this stage?
So, as you can probably tell, I'm not Mancunian. Although I have heard it said once if you've lived in Manchester more than half your life, you might be able to count yourself at least as an honorary one. So, and that is the case for me this year. So I moved to Manchester when I was 18. Had a lot of fun as a teenager and a 20-year-old at the university here, and then I've really much fell into to some degree doing to some degree, that's a pun, to a PhD with Professor Novoselov, or Kostya, who was the one of the Nobel Prize winners for the discovery of graphene, and that was sort of my trajectory was set, I guess, to some degree. So ended up working the last 15 years pretty much in advanced materials and technology development. Sometimes on the side of the university, sometimes on the side of startups. So up until a year and a half ago when we started Vector Homes full time, I was one of the managers, or the application managers, at the Graphene Engineering Innovation Centre, which you all know well.
So for everybody else, the Graphene Engineering Innovation Centre, what is it? What does it do? I mean, obviously we're part of it, and Concretene joined that, and we fully understand. But for everybody else, what is it? What is it for you guys, and what does it give you?
So I think I could probably fairly safely say, without the geek, as we call it, or something like it, I don't think we would be able to exist. So what it does is it provides a series of equipment, expensive equipment, which is vital for our testing, production, characterization of materials. But through the way that we access the building, we essentially split that cost across 20 or 30 companies as well as the university. It's a model that is replicated up and down the country in the high value manufacturing catapults. Providing that space and equipment for, what is quite an expensive business, which is trying to develop a better material, whether it's polymers, plastics, metals, ceramics, and so on. So it's providing that space for companies and the university to work alongside each other.
So from a Concretene perspective, I think for us, we see a real opportunity to create a kind of combined out product, because arguably the work that we're doing with graphene is application based. So we have applications, and we're arguably graphene supplier neutral. And to that extent, if our application works with the applications you could then holistically the whole set of products could be much better, and therefore you get a suite of products that come out of the Graphene Institute that everyone can kind of mutually talk about and work together on. So I would see that as a real benefit, which is good. So what else have you you mentioned affordable and social housing. I'm not sure. Are they not the same thing? What is the difference? Is there a difference, or is it just a free choice of words?
There's quite a distinct difference between the two, and I think we as Vector Homes fairly agnostic a little bit as to which channel we're delivering in. But in terms of social housing, there's much greater limitations on the on rent that could be charged on those locations whereas affordable housing is more relative to the area it's being built in, judged on averages across that area. So you can imagine affordability in Chelsea is much different to the affordability.
So why does that matter for your product? Surely you're going to charge as much as you can.
No, actually, we're very much set on trying to charge a fixed price for our product. That is, of course, not including the price of land, because obviously that is something we cannot do anything about at the minute. But I think, so up and down this country there are people that are unfortunately in a situation they cannot afford housing, decent, good housing, and that's regardless of where you are. We do not want to be just building what is quote unquote affordable housing in more affluent parts of the country, because that's not really serving the people that we kind of set out to address the challenges of. So
I think you've talked about the purpose of your company, but is the purpose fully about providing homes for people, and therefore kind of the social drive must be really critical, and therefore your customer base should be the providers of homes in deprived areas where you can really make a difference.
Absolutely, and I think we go beyond that because we're very interested in and are involved in some projects that are specifically for housing people that are homeless or that for some reason or other have had to leave their homes in strife. So we're very much focused on providing those, but at the same time not having to sacrifice on things around sustainability. So it's trying to provide that sort of dual purpose.
So when we were talking before we were in the pod doing this interview, we were talking about disruptors, and you were talking about IKEA, because the real thing about IKEA is you don't need to be a joiner to make a piece of furniture. So does that translate into what you're doing, or do I still need to be a skilled tradesman to build these houses? How disruptive is your technology?
So look, ultimately we would like to get to a point where anyone could build, with our system, build your own home, and it would be safe and it would be high quality. Now, the reality is, of course, there's still going to be a certain amount of certainly at least training that's required to build these. So when I'm talking about ease of build, we're talking about everything having pre-measured fixing holes, so you don't necessarily need a tape measure on site. Everything is cut to size, so you don't need cutting equipment. Even fixings made with things like rivets or screw rivets rather than nails and screws, and that speeds up the build, but also helps to prevent some of the issues around the quality of build as well. So we'd ultimately like to get to a point where perhaps going back to the model that Sears had in the late 1800s, early 1900s, where you pick a house out of a catalogue, it turns up on the back of a wagon, and you build it yourself somewhere in the middle of Kansas or wherever. But no, we're focused on that quick build, and I think that follows through, and then gives you all these other benefits around sustainability and so on as well.
So for the next steps generally, what for us as two startups working in the Graphene Institute, we're gonna keep talking. But is there anybody else out there that could help you that you really were missing that connection, or is there anybody who could potentially be listening to this that you'd like to get in touch and try and help you out? And if it was, what were the things? What's the bits that you really need?
Well, of course, we never turn down discussions with investors. I would say that first. But no, I think one of the key challenges to getting, making a meaningful impact with, which to me means we need to be building houses with our system, which we believe is lower cost and more sustainable. And I think would be interested to have conversations around the delivery mechanisms for that don't follow, your conventional, sort of client contractor relationships. We think there's possibilities to innovate both on that delivery side as well as the materials and systems. And I think really what we've tried to do is look beyond the materials to look at a sort of broader section of the value chain. And I think that's really important if you're that kind of holistic view is really important for some of these things like sustainability, which are now becoming sort of I guess, drivers, but for a long time have been more something we should be doing, but haven't necessarily been the cutting edge. Yeah.
You briefly mentioned investors. It's the first time in this little interview that you've mentioned it. Presumably, it's a no-brainer. Step through. It's not been a problem getting investment. I mean, it's a compelling proposition. It's a nanomaterial. It must be queuing at the door.
So I think, I mean, we have been luckily we've been lucky in that regard. We found some really good investors, people that are, understand the space, or if they don't understand the space, they kind of let us understand the space. But there are challenges broadly, I would say, with certain investors' expectations around what can be delivered in what time frame with advanced materials. So, of course, I'm talking a bit generically now, but if we're comparing to software development or app development, we're typically talking about longer time frames. There's more technological risk to a later date. Typically quite low in the value chain. All these things. So these are sort of things we try to address by the minimal business model we've got. But I think it's a matter of finding. Perhaps it takes longer to find the right investors. I would say. Let me put it that way.
So we've at Concretene we found it very. We found our investors very supportive, and you're right. You need a more patient investor, and maybe it's venture capital rather than private equity that you're looking for. But it's been great to explore all of these topics with you. We really look forward to joining you and as you open your first house, and maybe we can meet again when it opens, so we can follow up on our interview and see how it's all gone.
Absolutely. Thank you.